what is the role of colons on macro names? That is, labels have colons. They don't have to have it, they're supposed to have it. How to handle macro names with colons, like and I think what you should do is just ignore them. That is, allow this to be defined as such, but don't store the colon in the macro definition. It's wrong in an invocation, but it's not necessarily wrong here. It's done both ways. So if you have strip buffer D0, that's an error. Colon doesn't go in the macro definition. In particular, you don't want to treat that colon as part of the macro name. It's not. So when you process it, store it, you have strip as the name of the macro, but you just throw the colon away. But don't reject it as an error. You follow me? Other questions? Anyone? I have put up an FAQ on the project. There are 2 answers now, so if you go forward and I get questions from you guys, I will post them for everyone on that site. Okay, you all know there's no class on Wednesday. And then we will have our test next week. Yes?
For this program, do we have to create any public methods that you want to use, right? Or just call everything through the main?
Oh, okay. You should not print anything to the screen other than macro processing complete. But I don't need you to dump the macro definitions. You did that already. And so what I will expect for this final project is output in an expanded correct macro. So the definitions are removed, and in its place go the expanded macros. I have also placed another program up for you guys to work with in testing your Project 3. And this was written by a student this semester. So it's not floating around anywhere, something totally new, and you can use that to help grade your or to help test your program. I had an assignment where they were expected to solve a polynomial in assembler, and part of the project was to use as few instructions as possible. And I said macros don't count, we're not going to count macros. Well, in my mind, I'm thinking the printing of the answer, that shouldn't count against the total number of instructions they used. But one clever student essentially turned the entire program into macros. So he had only macro invocations, so his solution was much, much shorter than anyone else in the class. And his solution was correct, and he did get extra credit for that project. So you should not get errors when you process it. Okay, any other questions for you guys? All right, so the test is going to be next week. There's no class on Wednesday, and I want to talk a little bit about what's going to be on the next midterm exam so you guys can get prepared for it. So the first thing, I have a bunch of true-false questions, kind of like I did last time. And the goal here, again, is not to trip you up. They're kind of straightforward questions. But the goal is to help you out, because it's easier to recognize things than to remember them. So there's a fairly short number, small number, a dozen or so true-false questions. There is a linkage problem like we did last time. I told you it would be on the test, well, I put it on the test. So similar to what we did in class last time, there will be one of those on the test. There will be some short answer problems where I pose something to you and ask you whether it's a good idea or a bad idea. So there are two questions here that were on last semester's exam. So I'll tell you what those questions are, because you're not going to have them, and you can see the type of questions I'm going to ask. So I'm just going to read this for you guys, and then we'll talk about it. Suppose that a programmer is writing an SIC-XE assembler. Well, they were. That was their project for the semester, was the assembler. He reasons that if the source code is going to have a base directive, it must be immediately followed by an LDB instruction. He adds validation code to the assembler to print an error message and terminate the assembly if a base directive is not immediately followed by an LDB instruction. Is this a good idea or a bad idea? Then I had to circle your answer, good idea, bad idea, so I wouldn't have to deal with the waffling. When you ask students questions like that, I get lots of conditional kind of, well, maybe, and if this, perhaps, it might be. I wanted them to say, yes, it's a good idea, no, it's a terrible idea. So I gave them two choices, circle one or the other, good idea or bad idea. So it was, again, you have base, delta, LDB, pound sign, delta. So as you guys know, and again, we spent more time on assemblers in that class, so I recognize that. Your questions will probably be more related to macros. But this says turn on the base addressing mode. The base addressing mode is available, and use delta as the address for base mode. And then load the address of delta in the base register. So the question is this: is it a good idea or a bad idea to write code to check and make sure that every base directive is followed by the LDB? So what do you guys think? Good idea, bad idea?
Bad idea. Good idea.
I hear good idea, I hear bad idea.
No idea. No idea.
No idea.
idea.
Okay. Everyone understands what this does, right? If you don't ask, you should understand what it does. It's also important to point out that part of this is runtime and part of it's assembly time. I mean, you might be looking at that thinking, okay, you're going to use base mode, but why do you need two instructions? Isn't that rather silly? I mean, what's the point? Why not, just make one thing out of it? Well, when you're doing the assembly, can you get to the base B register? You're assembling the program and you're going to calculate displacements. Can you read the address in the B register? No, you can't. You're assembling the program, it's not running. So you can't access that register, it's not available. Even if you're assembling this on the same machine you're going to run it on, what that B register might have in it when you actually run the assembled program later on, you have no idea, and you can't get to it, you can't do it. Is this clear to everybody? Do you follow what I'm talking about? Does this make sense? Okay. So there's two different tasks going on here. This is assembly time. Since you can't read that B register, you have to know what address to use to calculate displacements when you're generating the code that's later going to run. Well, once the code has been generated and is now going to run, it reads out of this register, and there's only one way to get it there, and it's to put it there at runtime. So this is runtime. So it's important to understand the distinction between those two things. Is that reasonably clear? Do you follow me? At assembly time, you can't read that register because your program, what that register might have when you run it, how could you know? Later on, when you are actually running, what happened at another stage, the assembly stage, is not available anymore. It's gone. There's a similar idea here with location counter versus program counter. What's the difference between those, and why does it matter? Well, the location counter is available during assembly time. When you assemble the code, every instruction gets an address. You guys know this, right? So, okay, but the program counter is a register that holds the address of the next instruction to execute, and that's only at runtime. So location counter you use during assembly, but the program counter you use when you're actually running the program. And it makes sense. This example here, you're doing the assembly. Suppose you have P1.S, that's the name of your program. And these are instructions in your program. Okay, you're running the assembler, and you're assembling this program. When you're running the assembler and assembling the program, what would be in the B register? Well, but if there is something in it, the assembler's using it. It's the assembler program that's using the B register, not this program. So once the assembler program has finished and you have assembled this P1, then you run it. And when you run it, then the base register can get delta. But when this was running, the assembler was running, you couldn't read the address of delta from the register. Everybody with me? You follow me here? Questions? I know it's kind of an important distinction, and it's sometimes hard to pin down. The difference between compile time or assemble time versus run time. So some things are runtime, some things are compile time. Think of a better analogy to give you right now. Okay. So if you have Java code, let's say Java, you get an index out of bounds exception. Is that runtime or compile time?
Runtime.
Runtime. It doesn't happen at compile time. Well, why not?
Because it doesn't know it's happened until.
There's no array. Not till you're running the code. The array doesn't exist. You can't get the size. Can you get the size of an array that doesn't exist? Not really. No. You have to have it before you can get the size of it. So if you're writing code and you have something like ARRI, can you check and make sure I is in range? Well, if you know what I is supposed to be, you can. But if you don't know until runtime what the sizes are, there's no way. There's just no way. That's like saying, okay, I'm going to write a macro preprocessor, and rather than a vector, my macro preprocessor is going to store every line of code in an array. How big do I make the array? I'm going to store each line of code from the source in an array instead of a vector. How big do I make it? Well, it needs to be exactly the right size, so how big do I make it? Well, how in the world would you know? How could you possibly know how big to make the array? Do you want the assembler to work with one in one file only? Then that's kind of pointless. If it's supposed to work with any file, well, how would you know what size the array you need? And in fact, you can't. That's why we use a vector there. That's one of those things you don't know till a program runs. Then you get that information. Can you get the size of your vector once you've read a file in and processed it? Of course you can. But do you know when you're writing the assembler? No, of course you don't. When you're writing the macro preprocessor, do you know? No, you can't. So it's important to think for a minute, is this a runtime thing or an assembly or compile time? Make a distinction between them. All right. So, back to the question, is it a good idea or a bad idea? I think it's a bad idea. It's a bad idea, yes. Anytime you start demanding that the programmer write certain code, I think it's a bad idea. I was looking, however, to see how well the student understood the issue. And so no matter what they actually said, as long as they made a good case for it, they got all the points. All right, the next one. A programmer is writing an assembler again. He reasons that he can eliminate forward references and simplify the assembler if he requires all storage allocation directives to be placed before the start directive. That is, you put all the storage allocations first, and then you have the start and the code. So you have storage allocation code rather than code storage allocation at the bottom. That way all the references are backwards. And in fact, as you go down the line and assemble things, you will always have memory references that you've already found. This will eliminate forward references. Well, what's the problem with forward references? Again, as you're going through and you have memory reference, LDA alpha, but you haven't gotten to alpha yet, how can you encode it? And the answer is you can't. What you have to do is just do the addresses first, so you get the address of alpha, and then you can encode it. But you can't encode it until you know where alpha is. Everybody with me? So, by putting the data first, does that solve the forward reference problem? And so, yes, no, or why?
I think
You don't know where the memory location the operating system's going to allocate.
Well, I mean, but that's a given. So, I mean, it looks kind of, the idea is just this. Make sure everybody's on board. So we've got something that looks like, you know, alpha, word, 10, beta, reserve word, 2, start, PROG, start, 1000. So because these are behind or first, so what addresses would they have? Well, there's some issues with this, of course. What addresses do you give alpha and beta if you're starting here with 1000? So if you put alpha and beta here, then they have the addresses, but this is your first line that you're going to execute and you can't. So you would have to do something like, you know, J next, alpha, and beta. Next. Okay, well you could do that. I mean, you could essentially put them first. One way or another you could do it. So the question is, does that solve the forward reference problem? Does 10.
Doesn't that cause a problem? Because maybe the code goes on really long and then it won't.
Well, it could still, you have a memory reference that's too far back instead of too far forward. So yes, you are correct. But that wasn't